for coming. My name is David Neville. A few words by training. I'm a scientist, or I was a scientist, so I studied cognitive neuroscience, artificial intelligence. Then at some point I turned rogue and I decided I want to do something else inside academy. So as we always like to say, I still do science, just not in an academic sector anymore, but outside. The idea was a little bit, just very shortly, a little bit of history, because I found it personally very interesting. So when you look at the history of cybernetics, the origin started in somewhere around the 40s or the 60s with some engineers, it doesn't work of course, who tried to figure out a way to control the machine you see on the left. That's a very old steam generator, from what I understand, and basically their problem was, before in the factories you would have a human who would keep looking at the pressure, and he would basically pump it down or pump it up depending on what was the level of the pressure. So basically it's regulated by a human. This means the machine to be operated, you need to have a human worker for all the period. So they said, how can we do it in such a way that actually we remove the human control? And that basically led to the idea, well, we need to have a control loop. And that's what was the basic of the cybernetics, finding a way to have the system inform itself and basically auto-regulate. In this specific case, what they had to introduce is this part, which is called a volano. And it just simply means when there is more pressure, it starts spinning higher, but the higher it spins, the more it will close the pressure. And that basically auto-regulates itself. This is what is called first-order cybernetics, which basically means self-regulating the system by itself. Now, when though you keep looking at who developed or worked with the cybernetics, I was surprised because actually architecture is a field who kept pushing ahead this line of research. Whereas artificial intelligence kind of diverged on some other approaches, architecture really took it to the next level and said, okay, now that we have established this, let's say, point of view control theory, what comes next? So as an architect or urban planner, the problem was, how about when the observer, the user, becomes part of this control loop? So actually it's not anymore you observe the machine from outside, you become part of the loop. And that is what is called second-order cybernetics. In the field of architecture, this led to some authors, like Paul Pangor, I think, who proposed to have an approach to design a building which is very much algorithmic or computational. So you try to incorporate part of the human behavior within the same design of the building. And that's the line I want to give some examples. So, two examples from nowadays. On the top you see a biking path, which is in Eindhoven in the Netherlands. An idea was to basically extend the city, have the cities as an extension of your mind, which means we can embed technology who will make some parts of the environment more walkable, more bikeable. And this idea just meant, well, the lights at night, the path at night is illuminated by LEDs, which get charged during the day and discharged at night. So it's entirely eco-friendly, it's entirely sustainable, but again, it has the point that for the human user, it's much nicer to walk that path or to bike it rather than go in the dark. And even more, I found that there was another very interesting experiment in Chile in the 70s, which is called CyberSyn. What they tried to do is basically to build a system for helping the decision in terms of economic matters of the city, I think of the capital, which was based on human-machine interaction. So basically they had almost like 2001 Odyssey in the future, a number of seats where human experts would sit. Then there would be a recurrent neural network kind of system processing information from all the factors around the city, and this would basically inform the human experts. So they really try to integrate human-machine economic decision-making system already in the 70s in Chile, which I thought it was a very interesting example. Now, going on along the idea of smart buildings, this is, to my knowledge, and again, I'm not an architect, so allow me to go for this. The edge. So the edge is the smartest smarter building we have nowadays. It's located in Amsterdam, and his smartness comes from having being entirely sustainable. So actually it has something like 70% reduction in electricity. There is very little waste. It has specific features which makes it the ideal smart building. To go a little bit more in detail, well, what does it mean? Well, the whole building is cabled with two things, water pipes and Ethernet pipes. I thought it was funny because normally you would expect that you have water, electricity, but no, instead they totally removed the Ethernet because that is much more important to carry also electricity signals. But also they have these general communal spaces as a design principle, which means you don't have many small rooms, but actually you have a larger space where the focus is really on the interaction between the people, not much giving separate rooms. I didn't say, but the Edge is an office building, so it's meant for corporate work or for office. Even more, the building is highly automatized. So as I read throughout all the levels, you have these machines, this is like a Roomba, but other systems will automatically clean the building to the point that even the parking slot is actually automatized. So when you arrive, the bar opens by itself. A scanner, a network records your plate, interfaces with your app, and it tells you the meeting you have. So it's highly automatized, the whole building. And this to me was a surprise to the people from the factory, probably is gonna look familiar. They say they had all this new revolutionary idea for meeting booths. And actually it's very much what we have also here at the factory. The idea that you don't have any more meeting spaces, you have the booths down the hallway. And what you do is basically you turn them facing each other, and that becomes your meeting space all over your working, co-working space. Okay, now, what next? Well, would you say that this building is conscious? I wonder. No, I see some people shaking. No one's saying, yeah, it's conscious, so I guess we agree. To me, as a neuroscientist, I would say it's super smart. It's absolutely not conscious. For me, as a neuroscientist, consciousness means a system who is aware of its user, and it goes beyond a simple action-reaction behavior, like it's someone who can infer what you're thinking while you are sad or while you are happy. And well, in that sense, I think there are three lessons important from neuroscience of why consciousness is really a hard thing to tackle and embed in any discipline. Well, first, consciousness is not one thing you can define univocally. In research, well, it has been shown that consciousness can be defined as the threshold of a visual illusion. So I guess most of you by now see the two different patterns in this picture. The one which you don't see is actually the pattern was fell off of your consciousness. But also, on the top, is actually a brain EEG signal of patients who are in coma. So there, the consciousness is actually a specific activation over your brain state, which have a particular pattern. And third, there is actually the question, well, would you actually assign consciousness to animals? Because you can see their system from outside, but you don't really have a way to define it. So the lesson I want to take from here is that to have a conscious building, I think it makes sense to look a little bit at how we are built ourselves, because of that thing you can be sure we have consciousness because we are observing ourselves from within. So if you doubt everything else, you shouldn't doubt yourself that you're a conscious being. As you said it. Now, it's all fine, but then let's zoom in a little bit. So the brain, if you look at it as a machine, I personally think is pretty amazing because it has an insane number of neurons. So I put the statistics there because for some people it's really important to see the numbers. To me, 100 billion doesn't really say much, just beyond. It's a lot of neurons. It has even more synapses, which is the connection between neurons. But the real kicker is it's a really slow moving machine. Like the speed at which electrical signals go through synapses is rather slow. So it takes actually 100 milliseconds when you perceive an item, which is from here where you have the eyes, to have all the signals sent back and then look forward. By the time it goes back forward, you know what you're seeing. This takes 100 to 100 milliseconds, so it's not a very fast machine. What is smart is actually how it is organized. And just what the thing I would like to highlight with the picture, which by the way, this is the combination of a lot of scans of all humans, and it's called the Human Connectome Project. It's the idea to try to map out the entire connectivity structure of the brain, which, well, you can see a quadrillion synapses is a lot of stuff to map. And the message here is that you have somehow a scale world structure, which means you have major pathways, the blue here, where you transfer information and direct here, but then you have local hubs, architectures, as you see here. So actually there is an area in the front, the posterior visual cortex. So you can see that there is a major pathway, the green one, and then apps or satellites around. That's basically the scaled world connectivity of the human brain. Now, it is remarkably similar when you look at, for example, how the internet looks like. So in the idea that we're moving toward Internet of Things space, where you have massive interconnection of different devices, and actually we are approaching a 5G speed of transfer, which means the amount of data and the latency is much smaller than the human brain. Well, it seems to me that the connectivity combined with this high speed, it's already in that sense much more than what the brain has. So given that the brain is much simpler, a smaller system, it can generate consciousness. I like to start thinking, well, is this enough to actually generate a conscious building or system? Is computational power all there is to actually achieve a conscious, in this sense, building? I would say no. Now we go a little bit more on the AI crunch of it. How many of you are familiar with the trolley problem? Okay. Still, for the sake, I will explain again. So, the problem is this one. Imagine you are sitting next to a railroad, and for some reason you have access to a lever who can change the side tracks of basically of a moving wagon. Now, you see that down the line of the moving wagon, on one side of the track you have one per person who is tied there. And let's say he's a child. On the other side, you actually have 4 adults. Your choice is, what do? Do you pull the lever to save the child, or you pull it to kill the 4 adults? So basically, that's the dilemma. What do you choose? This is important because self-driving cars, it's where they're struggling. It's a very problematic choice when you program an AI to somehow code morality, and that's really one of the hard problems. Like, how do you define the weight for a machine of what is more, well, I don't want to say killable, but yeah, where do you take the balance? Especially if you start introducing different factors. For example, is your loved one more important than a stranger? So should the machine actually keep track and say, oh, if I can save your partner or loved one, yes, otherwise I'll kill all the others. Like, it's a very complicated problem. And the question I got stuck is, can we program to actually make it formal, the morality in the first place? Like, can you even write it out? What is a moral problem or solution for it? The point then of combining what I call it second order cybernetics or AI is the idea that actually AIs can do much more in this sense. They can become an interface for the user with, let's say, a smart conscious environment. Because the amount of complexity is just too much. So in my view, I like to think that AIs could become this necessary interface. You're much more than your simple assistant. And how would you go about this? So I don't know how of you are familiar with deep learning in general. No one? Very good. And also, I guess, with chatbots. So one of the applications of deep neural networks, it's a lot of, so there is a lot of hype on deep neural networks, but it's one of many approaches. Some of the things apply to any kind of problem. So chatbots, I don't know if you ever tried them, they have been around for a very long time. It's the idea that you program a computer to fool you or do conversation with you. It has been, incredibly easy to fool them because in the beginning they were really simple. By the third sentence, they would throw at you a different combination of words which, just that this doesn't make sense. If you go now, let's say on Vodafone website, actually there are chatbots who are mixed with human helpers. And I tell you, sometimes I really couldn't tell if it was a very sophisticated chatbot. When I look at the science behind, they use a very smart way of doing machine learning. So it relies on 2 different steps. First, you take the word that, let's say, you are typing in when asking a question or training them, and you translate them in a numerical representation. So this is just a standard parser for a text. You start from the goal state, and then basically you map out all the sequence of letters or words or whatever until you arrive at the end of the string. So this allows you to map text to numerical space, abstracting any kind of a relation in my life. In the next step, you put them in this recurrent neural network. Like, to not go into the detail, what is important to note is the input comes from the left, all of your numerical vectors. gets chained through time between different nodes. So basically each node sees what he has seen before the other node and feeds it into the next one. It's like a chain of reaction. And at the output, you basically have the combination of all. What this thing does is extremely good at predicting what comes next and keeping track of the context. That's why sentence or language processing is really good. But it has been applied for a number of cases. The idea of deep learning models or GANs is actually, you take one of these and you pitch it against another one. So when you look, for example, at these videos which are showing about deep fakes, it's basically the idea you can have two networks, one against each other, where one tells always the truth. So let's say it produces paintings from Van Gogh, and the other one tries to modify them in a way, like let's say Van Gogh becomes in the style of Monet. By doing this, basically one is the fabricator and one is the judger. When they start to work in tandem, you get basically, you can transpose, let's say, the face of Obama in entirely a new video. So actually you get what are the deep fakes. You project the face of someone on something else animated, so you can actually make them look like they made a speech they never did. It's really a little bit like face-off movie. You take the face, you apply the pattern on something else. So it's actually a very high level, very powerful mapping problem. I'm going towards the end of my part, so my idea with all this large walk through AI is that, well, this is an example when you take two AIs and make them, put them together and have them talk to each other. And they're really powerful. Now, they're powerful because what they're doing is basically they're walking through a surface, a space of a problem which is really complex. If you represent it as a mathematical surface, and the goal for you is to find the point which is lowest, well, there are many different pathways. So for me, morality or consciousness is also a very highly dimensional, highly problematic pattern. So one way maybe to think about it is to think, well, have a bunch of AIs talk between them and try them to reason about the problem. So in that sense, the trolley problem, I would find interesting to see how two or more AIs pitch against it. So since you cannot code morality, try to have different AIs who discuss between them. And this, for language development, where I come from, has showed a major advancements, because what you couldn't describe, you suddenly were able to detect it when you took computer programs talking to each other. And in that sense, where do DLTs come from? Now, how many of you are familiar with blockchain system or distributed ledgers? Something? Okay, good. So the basic idea is that you have a database, a shared knowledge system. It's a list of shared by everyone, which tells you what was moved, who sent it, and who received it, and other types of information. A new action or transaction gets validated first by solving, let's say, a puzzle or having a proof that it's legitimate, and then gets incorporated in the shared repository by attaching it to two nodes which were already present. And in the end, you get something like this. From the beginning of time, you have a first transaction, then multiple transactions come in and basically link to that, to the previous one. So it becomes like a reverse tree for me. Going from time, it grows out from the origin. Now, this is something which Dan will go much more in detail after me, and will explain you how we simulate this, but this is in the real case how you would see that's called a triangle looks like when you have something like 45,000 transactions attaching to each other. And well, you can see here, but the resolution is much deeper. So there is a lot of self-organization here when you look at how this evolves over time. My final idea and pitch is, well, actually we can use the protocol, so the mechanism to have all the different transactions be validated and reach agreement and trust in such a system to coordinate, for example, multiple AIs, or human and AIs in the same smart environment. So you really need a proper way to handle communication and agreement between parties, especially when it's human-machine environment. And this then will allow you to, for example, reach a democratic consensus, which is one of the mechanisms, technologies we have implemented. There the idea is that if you have to figure out who is lying between, let's say, your commander who tells you attack or the lieutenants, well, the moment you have three people who are talking to each other, you can be absolutely sure that if there is disagreement between you, it has to be the commander. So you become a democratic consensus system. You don't need anymore an oracle or a verifiable, a single source who tells you what is true and what is not. And now I think we can have a break or any questions. I hope I didn't go too fast.
Originally, anyone that creates this AI or where it comes from, because obviously they all believe in structure and discipline, and there would be not many. Morality would need to be structured and discipline, right?
Yeah. Yeah.
Or even more, like they would say, let's go further. So it seems that it just amplifies the original bias. You need to have like a lot of them, and you need to make sure they're different, or
Yes.
that they contribute to each other.
Yeah, no, it's a good point. Like, definitely you can have a lot of them and they are biased also because the way they learn is by the data you expose them. So the input data.
If the past was,
It's biased, you're not going to get out. One idea I personally like is, so the AIs, I think they can learn a lot from biology. So how do you go beyond the bias, let's say, of your parents? Well, when you have evolution, so you mate, you mix DNA, you have mutations, a new iteration of you comes out, which also gets something from the other partner. That's a very smart way to having variation in a system. The same thing can be done with AI. So actually, if we had a community of AIs, then I would see, well, yeah, you have evolution. Yes, yes. It would be a mechanism to introduce variability and mutations. Sometimes there has to be, it's important that there is someone who is the outlier of the group of virtual. Because if everyone thinks the same, I agree with you, it would be a very dystopian view actually, because one argument around this is, let's say you have an AI who is really trying to integrate as a conscious city, so it keeps track of how many workers are being lifted off from a factory, or how many people die on the street. If it's a pure machine who is evaluating this, then what it might do is actually keep going with the idea, well, it's better if we have 10,000 deaths less over the year than today. So actually it would equate human life with just 1 gallon of water. So it would lose totally the dimension of what does it really mean to actually live someone. So losing a job is not like losing your life, to make it an easier case. And that would be one of the problems having all the AIs taking the same.
But I mean, to comment on that, in evolution, we have evolutionary pressure that selects for or against organisms. How do you extrapolate that to AI? Like, what is the evolutionary pressure there?
Even a harder question. I honestly don't know, because the evolutionary pressure should be normally something which, well, the AIs were better at doing their job, so have a highest fitness score, survive better. It's a matter of survival, so the ones who are better at surviving should be kept and propagated. It should survive the selection round. What is an AI which should survive? So, with the example of the factories, if you have to leave a lot of workers and your job is to try to integrate these people as possible in other roles within the same factory, I would say the AIs who should survive are the ones who reduce the letting go rate of workers. If the AIs are actually focused on the self-driving cars, yeah, there it becomes much harder because, well, the best ones could be the one who reduce the number of accidents across an entire city, but another one could be actually the one who tries to reduce the very dangerous accidents and maybe does not so well with minor accidents. So it's really able to avoid, well, that probably is going to be an event which will kill the person, this one maybe not, so let's go for the one where maybe the person survives. I honestly don't have an answer to that, of what is the pressure, the proper pressure for this mechanism.